Okay, so here's the Excel analysis of our optics lab. So you can see that I've opened up a spreadsheet and I've entered in this cell air to plastic, in this cell plastic to air, angle of incidence, angle of reflection, same here, angle of incidence, angle of reflection. Now I'm going to make some changes at the columns, but I wanted to do this, I didn't want to do it ahead of time. So the first thing I'm going to do is I'm going to fill out this column, which goes from 0 to 9 to 85. Now we may truncate this after we look at the data, but for right now we're going to look at all the data. So we go 0, 5, and then we can automatically fill it in by highlighting these two cells and then dragging it down. I don't know exactly how far. Well, I guess it would be 85, let's say 90 divided by 5, which would be what? 90 divided by 5, 18, is that right? 18. So I need to go at least 18 cells down. Okay, so I overshot it there a little bit. So just delete that. Okay, now here, when I go from plastic to air, I don't have to go as far. So I'm going to go to 40 or 45, depending upon what your situation was. Okay, now I'm going to enter the data. So I'm going to pause. You can enter your data. Okay, so there's the data that I have entered. So for the plastic to air, the second part, it turned out this set of data went 90 degrees at 40. Angle of incidence of 40 gave an angle of reflection of 90. Now if you got something different than 40, like 42, enter 40 and 42. So the last number should be whatever the angle was for you to bend 90 degrees. So I'm going to go ahead and delete 45 because I don't have any data there. Now, what I'm going to do is I'm going to plot the angles, one angle versus the other first, and then we'll plot the sine of the angle. So ultimately I'm going to have to probably do the sines of the angles as well. But let's look at the one angle versus the other. Okay, so let's look at angle of incidence versus angle of refraction. So we're going to highlight the two columns. We're going to insert, scatter plot. We'll choose one like that. So there's your chart. So let's put it on a separate page. So I'm going to right click and move chart. Create new sheet. We'll call it, what do we want to call it? Air to plastic angle. V angle. Okay, so that's how I'm plotting it. So you can see that it's not linear. It has some curvature to it. Let's go ahead and put some titles on here. So we'll call this air to plastic dash angle V angle. And then we will click there and we'll push the little plus sign because we want axis titles. And we don't need a legend because there's only one set of data. Okay, that's good. So now we have the axis titles. So the x-axis is the angle of incidence in degrees. And did I spell that right? Yeah, I think so. Okay, and then the axis title over here is angle of refraction in degrees. I'll delete those extra bit. Okay, And let's just make the font a little bit bigger. Not too big though, I don't want to go crazy. Okay, make the title a little bit bigger, and the numbers a little bigger too. Okay, so that looks pretty good. Now, I'm not going to fit a curve to this yet, but I'm going to use this chart later. We'll make a copy of this chart so I don't have to redo everything. I'll just have to redo a few things. So let's go back to the data. So I'm going to insert two columns. So I highlight the columns. So I don't highlight in the cells, I highlight the columns. And then I right click and I say insert, and it inserts two columns. And what I'm going to do here is I'm going to do the sign of incidence. I'm not putting angle in there because I don't want to add extra words. Sign of reflection. Okay, now one thing is that Excel always does radians, so we're going to have to convert degrees to radians. So we're going to say equals sin. You can see it shows up as one of the functions. Left parenthesis. Then I will click on cell A4, but I need to convert that to radians. So I multiply pi. And to do pi, you do pi and you do the two parentheses. I'm not sure if you have to use the parentheses, but I'm going to do that. And then you divide by 180. And then a right parenthesis. So that'll give you the sign of 0 degrees. And then I can copy that all the way down. So this is the sign of the angle, which should go between 0 and 1. And I can also copy this as well. So if I took this and I copied it sideways like that, it'll copy the formula. And because I didn't use any dollar signs or anything like this, it's going to increment. When I move this copy over here, it's going to use this cell. So you'll see here it says sign of B4, which is this cell, whereas this one says sign of A4. So it's in the right place, and then I just drag that down. So I get that. Okay, now I could go ahead and replot everything, but what I'm going to do is I'm going to click on the tab that's the first plot. I'm going to right click. I'm going to say move or copy, and then I'll say create a copy, and I'm going to move it before sheet, the current sheet, so I'll move it to the left hand side. So you see it says air to plastic angle versus angle parenthesis 2. So what I'm going to do in this case, we're actually going to plot the sine of the angle. So double click on here so we can change the description to sine versus sine instead of angle versus angle. Okay. Let's go ahead and change the titles here. So we could say sine of angle versus sine of angle. Okay, same down here. Except we'll say it's the sine of the angle of incidence. And the same way over here, the sine of the angle of reflection. Okay, now we still have the same data yet, so we're going to have to choose some different data. So the way you do that is you'll see that when we clicked on the graph, you have this choice of design and format. So we're going to design it, and we're going to select the data. So here is where the data is selected. and it's selected A4 through B21. What we want to do is click on here and then highlight these cells instead, and then push enter. So now it's C4 through D21, and we say OK, and we get that. So that looks more linear. If we do angle versus angle, or sine versus sine. Now what we'll do is we will fit a curve to this to find out what the slope is, because the slope will be the ratio of the indexes of refraction. In this case, it will be the index of refraction of air divided by the index of refraction of the glass. So it'll be a number less than 1. Okay, so we're going to click the data. We're going to right click, add trend line. We're going to do linear. We're going to display the equation on the chart, and we are going to look at r squared. Okay, so that's that done. And if I click on the equation, it's kind of small, so if we highlight that and go to home, we can increase the font so we can see a little bit better, and then we can move it a little bit to one side. How do we do that? Click on it, and we should be able to drag this thing somewhere. There we go. Okay, so you can see the r squared is 0.9954, which is pretty good. It's not perfect. And y is 0.6848. So if you take a calculator and you take the reciprocal of that, so 1 divided by 0.6848, we get 1.46. So that's our, because the index of refraction for air is approximately 1, we get that the index of refraction of the plastic is 1.46, which makes sense. Okay, so that's the first part. Now, what we're going to do is we're going to now do the same thing, except with the second bunch of data. So again, rather than re-entering everything, what I'm going to do is we're going to click on this air to plastic angle versus angle, and we're going to right click, we're going to create a copy, let's move it to the end here. So now it's tab there, and we're going to do plastic to air, so let's change the label. So we'll double click on the label and get rid of that 2. The 2 means it's a copy. Okay, and we're going to do flip it around. So it's going to be plastic to air. Okay, so we've done that. We don't need to change the axes labels because they're still angles. We do need to change the title. So it's plastic to air. And then we're going to choose some new data. So we're going to say select data. And we'll click on chart data range again. So we'll go right there. We'll highlight that data. We'll say OK. And now we have that. Interesting. Oh, yeah, because this is the angle, so you can see how it bends at the end. So actually, we're done with that one. So we've got the label right. We've got a curve. We didn't fit a curve to it because we're going to do the next one, which is the sine of the angle. So we'll click on the air to plastic sine versus sine. On the label, on the tab, we'll right click. we'll create a copy, move to the end. So now here it is. So you can see that's well, this is the old data. We got to make the changes, a few little changes. We got to go from plastic to air. Okay, that's fixed. Got the labels are correct on the axes. So we need to select the data. So we go chart data range, highlight this. Oh, except cancel everything here. We've got to go back to the data and do the sign. So the best thing to do would be to copy these. So I'm going to do Control C, Control V, and then I'm going to just copy the equation. So I'm going to highlight there, and because everything's relative, the same relative position, I could just copy that one equation to everything, and so we get that. So that's our data for the sine of the angle. So now we've got sine versus sine, so we can go back to the tab, and I just realized we're going to, what are we going to do here? We got to change the title here. I didn't do that earlier. So it's plastic to air. And let's get rid of that little extra 2 thing. Okay, so that's good. Okay, now last thing we need to do is change the data. So click on the graph, go to design, select data, chart data range. So we're going to plot sine versus sine. And hopefully this is more linear. Yeah, there it is. Look at that. So, and let's look at the slopes here. So this is the slope 0.6848. When we go to the other graph, which was sine versus sine, we got 0.6848. So it's the same thing. So actually there is a problem here. That's too much of a coincidence. So something's wrong. And what's wrong, also it looks like the data fits better. So what it did was it copied the equation. So we get rid of that. So we highlight it and push delete. And the other thing was it should be the reciprocal, since we've changed, so it should be more like 1.4 something. So the way we do that is you would click on the trend line and delete that. Okay, so I got rid of the trend line, and then we'll add a new trend line. It actually did fit the trend line, but let's just be sure of everything. So we're going to right click on the data, add the trend line, we're going to go linear, we're going to display the equation, and we're going to display r squared, and we get that. Now it's kind of small again, so let's click on the equation, highlight the data, or highlight the numbers, pick a bigger number, and then hopefully slide this thing to. So this is interesting. So here we're getting y is equal, the slope is 1.5457, which is higher than the value we got here. So the question is why? Now, one of the things we saw was that the when we did the first set of experiments, the angle after a certain period was very difficult to delineate. So what I may try here is if I only used, say, the first 10 data points, where it was easier to read the angle of refraction, to see if that affects things or not. So how would we do that? Because I may not want to get rid of this. So what I'm going to do is actually copy this again, and I'm going to move it to the left here. So now we've got everything's fine. What I would do is I would click on the graph. When I choose my data, what I'm going to do is I'm going to choose a smaller portion of the data. So let's just do up to about 60 degrees instead of all the way up to 85 degrees. Okay, so now it looks like that. Again, the equation is wrong because that's based on the previous calculation, so I need to delete that. Let's click on the trend line here. How do I click on the trend line? Click on the trend line, see if that lets me do it. Why isn't it letting me do that? Format the trend line. So in this case, I'm not going to delete the trend line because it seems like it's accurate. I just have to go back here and click display equation. That looks like it's even worse, because if you look at y, it's 0.7038. So if we take the reciprocal of that, 1 divided by 0.7038, we get 1.42. So, interesting. So I've never, in the past, we've just kind of qualitatively looked at these things. I have never actually plotted these things out. So I'm going to actually just forget about this new data. It didn't really support my view, which I guess is it supported the view that there's a difference between going one direction or the other. So I don't know if that's true. We'll see if you guys, with your data, if you see the same thing. So I'll be interested in that. But I'm just going to delete that sheet. Okay. So that is it for the angle of refraction and angle of incidence. I don't like this complete particular order, so I'm going to move the data to the left. So it's refraction, air to plastic, air to plastic. Let's move this to there, so it's air to plastic, angle, angle, air to plastic, sine, sine, then plastic to air, and then plastic to air. So that has some kind of logical sequence of data. Okay, so that is the refraction stuff. Now the question is, do I want to create a new spreadsheet for the other data? I think the answer is yes. So we're going to save this, and we'll save it as, so let me find, this is lab 11. So you're going to have to upload 2 Excel files here. So this one is going to we'll call it refraction Excel analysis. Okay, so that's the Excel for the angle of refraction. So yeah, the most interesting thing here was that the angle, or the ratio of indexes of refraction was different depending upon which way we went. But I'm not using my data, I'm using somebody else's data. And maybe their setup is different than other people's setups. So like I said, this will be interesting to see what the rest of you guys get. Okay, so we're going to create a new file here. This will be the one for the refraction stuff. Not the refraction stuff, but the lens equation. So what we're going to have is we're going to have a column which is the object distance. We're going to do it in centimeters. So if you did it in millimeters, you can either change it to centimeters, you can just label it. And then you have the image distance. Now what we're going to do is we're going to have so that's the measured, and this is going to be the calculated. And over here we're going to put the focal length. So focal length is 75 or 7.5 centimeters or 75 millimeters. So here is where you'll enter your data. So these numbers should increment by 2 centimeters. So I could have actually done that the short. Let me do it the other way. Instead of entering them, let's just put the first two numbers in and then go down to the extent of the object. And then the image, let's see what we got. Okay. And something looks a little fishy. I can't decide what it is. I think this is a 727. We'll find out. So again, this is not my data, so I'm not 100% sure. Now, as far as calculating it is concerned, what we'll do is use the lens equation. So let's pause for a second. Let me get up a sheet of paper. Okay, so what we're going to do is we're going to calculate the image distance based upon the focal length and the object distance. So we have 1 over p plus 1 over q is equal to 1 over f. So we're solving for q. So 1 over q is 1 over f minus 1 over p. And if we take the reciprocal, it's going to be 1 over f minus 1 over p raised to the minus 1 power. And I'm doing it this way because it'll work better in the Excel file. And f in this case is 7.5 centimeters. So we'll have negative 1 over 7.5 minus 1 over p, and then take the reciprocal of that. Okay, so what I'm going to do is I'm going to move this to the other Okay, so I've moved that equation to the other page so I can see it. So we have equals 1 over 7.5 minus 1 over p. P is this number here. Right parenthesis raised to the minus 1 power. So that maybe that number was not 27. Maybe it was 22. Okay, so now we're going to copy that equation. I didn't use this number here in the equation. I mean, I did use it, but I didn't use this cell, but that's okay. So I'm just going to copy that down. And so there we go. Now notice that things change here at, so twice the focal length is 15 centimeters. So when the object is more than 2 times the focal length, this is where it starts to act as a camera and the image gets small. This is where it's acting as a projector. And actually right here, they should be fairly equal to each other. Okay, so that is what we're going to do. We're just going to create one graph that compares object distance versus image distance measured and object distance versus image distance calculated. So I'm going to start with, actually we could just highlight the whole thing. And then we're going to insert chart, scatter chart, and there it is. And let's right click on the, highlight the chart, right click the chart, move chart, do new sheet. So we can just say it's a graph. Excuse me. And it's a graph. Let's double click on the label for the sheet. Call that data. Okay, let's go back to the graph. So we're going to have to make some changes. So let's do the chart title. We'll call lens equation versus measurement. Okay. We'll click on the graph. In general, we'll put the plus. We need axes titles. We need a legend. Okay. So let's just go through here. Let's do the title, make it bigger. So we'll go to Home, Font, 16 point. The x-axis is the object distance. So we'll highlight that, put in object distance, and units are centimeters. Okay, just click outside of that. Let's go over to the other axis. If you double click a couple times, you'll get to a point where everything will be highlighted, and then we can do that. So this is the image distance in centimeters. Okay, not push enter, just click anywhere else. Those are kind of small, so let's click on those and go to Home, Font, 12 point. Do the same thing on the x-axis, 12 point. Let us change where the legend is. So click on the legend, right click, format legend, top. I always like it on the top. One thing you'll notice is there's no names for the legend part. So to correct that, click on the graph, go to design, do select data, and series 1 would be the measured image. So I'm going to click on series 1 and click edit. It doesn't have a name, so I'm going to call it image distance measured, and then click on series 2, edit, and call it image. I don't know whether I need to actually put, let's just say let's do it calculated and measured. We don't need all that extra stuff in there. Okay. Okay, say okay. I want to make the legend a little bit bigger font. It's pretty small. Okay. Did we change the font? Yeah, we did. Okay. Might even make it even a little bit bigger. 14. And let's change the numbers, make those bigger. So click on the axes, change those to 12 point. X-axis, 12 point. Okay, so that looks pretty good. So what is this telling me? It's telling me that maybe I messed up on the measurements. First couple of measurements, I don't know. Well, again, we'll see what other students get and see how well they compare. But I'm not going to fit any curve to it. I guess you could do a reciprocal curve. Let's see if that actually works. So just curiosity, click on the orange data, do right click, add trend line, and we'll do the, let's see, I don't know if you can do order -1 or not. No. Okay, that's not going to work. How about power? That doesn't look very good. Exponential. Nope. Okay, let's get rid of that. That's not really helping us any. So I'm going to delete the trend line. Now, one thing we haven't done before, so let me show you one more thing, is you can make these symbols different size, different colors, different shapes. So I'm going to click on, right click on that, and it says Format Data Series. And I think if you come over here, you can change the marker. So you can change it to a bigger marker. So I think if I did, actually that's the the marker. Let's see if that works. Are those bigger? Yeah, I think they are bigger. And then if we click on the other one, and I think if we just click on it and we go to this side, and again the marker is the little dot. So if we go again, increase the font, see now you can see they're bigger dots. So you can change the dot's shape, you can change the dot's size, you can change the size of the dot if you want to. And last thing, I'm just going to move the graph to the right. So we have data, graph. Okay, so that's it. We're done.